Of today's lecture is how do you document a Java class. Now, documenting code is not new to Java, right? So people have been documenting code since as long as they've been writing it. I would argue that Java was probably one of the first major languages where you would embed the documentation in the code, and then you would use a tool to extract the documentation into a readable electronic document. Right. So one of the reasons this happened is because Java came out in 1995, which was just about when the internet started to become very popular. Right. So the internet started becoming early 1990s is when it first came into use, and then it very rapidly became extremely popular. Right. So about mid-1995 is when is when a lot of ordinary people would have access to the internet. So the tool that generates API documents from comments embedded in code is called Javadoc. Now there's a bunch of these tools that are available, not just for Java. So just quickly over here. So this is what is this nonsense? There we go. Okay. So this is the tools that do this sort of thing are called documentation generators. There aren't that many of them, but there are quite a few. So Javadoc shows up here in 1995. And you can see from the table here that a bunch of other ones started to show up in the mid-90s as well. Right? So here's one for C that showed up. Where's the other one? You guys didn't use deoxygen, did you, in your C course to generate documents? OK. So deoxygen is I would argue it's the main documentation generator for C. It showed up in 1997 in its first release. Now, funny enough, there is an earlier one. So there's this, not PearlDoc. Where is it? Where to go? 90. There's one in the 80s. 89. MKD. So this is a tool that was this was a tool written in Unix that could generate documentation from any sort of comments in code. It showed up in 1989. So this idea of generating documentation directly from source code is not a new idea. All right, but I would argue Java was the first major programming language where it came into widespread use. So the way Javadoc works is it reads your source code, and it looks for these things called doc comments. So a doc comment, you've seen them in your labs. Right? So those big comments that show up in front of every method in your labs, those are Javadoc comments. They're multi-line comments, so these start with /*. Javadoc comments are special. They have a second star after them. Right? So anything that's inside /** and //, Javadoc will read that comment and try to interpret that as a Javadoc comment. Right? Now, whoops, sorry. So because Java documentation is meant to be read online, the comment is generated in HTML. Right? You can also write HTML in your comments if you want to. So every comment basically has a description. So either a description of the class, the constructor, or the method. Right? That description is extracted by Javadoc and put into the documentation into the document that describes your class. Then there are these things called tags. Right? So anything that begins with an @ inside a Javadoc comment is considered a tag. There's lots and lots and lots of these tags. We don't try to tell you about all of them in this course. Right? The ones that you need to know about are @param, @return, and @throws, and I'll tell you exactly what those do as we go through the lecture. OK, so when you start to document your class, the very first thing that you document is the class itself. So every public class should have a Javadoc comment that describes the purpose of the class. Now, when you describe the class, the idea is that you describe why people would want to use your class, what features your class has, but you don't tell people how the class is implemented. Right? So in other words, you don't go into all the nitty-gritty details about what fields the class has, right? What private methods the class has, what algorithms the class uses. Right? The point of documentation is not to describe how a class is implemented. Right? It's to describe the purpose of the class itself. So for the point2 class, you might have a little comment like as follows. Right? So for the point2 class, we can write that the purpose of the class is that it represents a Cartesian point in 2 dimensions having real coordinates. right? If you were writing professional quality documentation, you would expand on this comment, right? So you'd explain to people what methods the class has. Right? You might explain, you might give examples of how to use the class, and you might explain any limitations the class has, and so on and so forth. Right? So if you were to look at, for example, the documentation for some of the Java standard library classes, like string, right, you'll see that. So this is the part of the class. This is the documentation for the class, right? So it goes on and on and on for quite a while. Right? So if you look at some of the standard library classes, and you look at the class documentation, you'll see that there is normally quite a lot of documentation to describe to programmers exactly why you'd want to use this class, what feature the class has, what limitations it has, and so on and so forth. Okay, so when you run the Javadoc tool on just this little class right here, right? Notice the class only has a comment and the fields. There's no constructors or anything in this class. If you run the Javadoc tool, you end up with the following. Right? So this produces a web page that looks pretty much like the standard documentation for the Java standard library classes. So up here, you'll see the name of the class. Right? You see the package that it's in. Here, you can see that point 2 is a subclass of object. We'll talk more about that in a few weeks. Right? And there is your description of the class. Right? So that appears at the top of the class documentation. If you have a public field, then you should document that field. Right? Describe what is the purpose of the field using a Javadoc comment. Right? So in the math class has 2 public fields, e and pi, right? Representing Euler's number and the mathematical value of pi. And you can see that they have a little comment that explains exactly what these are. So if you run the Javadoc tool on this code here, right, it produces the following. Right? So it produces something called a field summary, right? And then it lists the fields that are in the class. Right? So there's a static double field called e, there's a static double field called pi, and the description goes here. Okay, notice what's not here though, right? So what's not here is the value of e or the value of pi, right? If you're ever hunting around for the value of a constant, then you have to click on the thing. So I can't click on this because this is just a screen capture. But if you click on the link that's here, it'll take you to something called the detailed description of the field, and there you'll find a link that says, I forget what it says, constant field values. You have to click a second link to actually find the value of the fields, right? But somewhere you can find the value of pi and the value of e, right? It just doesn't show up here. All right, so if you have a constructor and it's public, then you should document it as well. Right? The first sentence from your Javadoc comment, that appears in the constructor summary. The rest of it appears in the constructor detail section. So for our no argument constructor, we want to describe what is the purpose of the no argument constructor and what does it do. Right? So it initializes the coordinates of this point to 0, 0. Constructors and methods in a class, they represent actions that an object can perform, right? Or that a class can perform. Right? Now, because they represent actions, it's recommended that the first word of your documentation start with a verb to indicate that this thing is taking some action or performing some action. Right? So constructors always initialize the state of an object, so initializes is always a good choice for a verb to start your documentation for a constructor. If you're wondering what this funny @code business is, right? So there's another tag here that's called code, and it's inside of braces. So what this tag does is it formats the rest of the text. So when the documentation is generated, the text that follows the code part here is formatted using a monospaced font, right? So a typewriter style font where the spacing of each character is the same. Let me just jump ahead quickly. So when you generate the actual document, right, that code, the stuff that follows @code gets formatted in a different font, right? And so that is so that it stands out from the rest of the text. So typically, if you're referring to a field or a parameter or some fixed values, you can format those using @code. In this course, I don't care if you do it or not. Right? In other words, so I don't mind if you just write that as bracket 0.0, comma 0.0. Right? The formatting here is not something that is important for the purposes of this course. If you're writing professional quality documentation, then the way your documentation looks is important. Right? And then you would spend time actually formatting it nicely. Okay, if your constructor has parameters, then back here. So when you describe what the purpose of the constructor is, right? Again, you only describe what the constructor does. You don't explain how it does it. Right? It's not unusual to see student documentation that says something like, initializes the coordinates of this point by setting this dot x to 0 and this dot y to 0. Right? No one needs to know that there's a this dot x or a this dot y. Right? All you have to say is what the constructor does. Right? You don't explain how it does it. Okay, so any parameters that your constructor has, they should be described using @param. So when you describe your parameters, those go at the bottom of the documentation. Right? So this constructor has two parameters, x and y. Right? So you document the parameters, so it's @param, name of the parameter. Right? And then the description of what the parameter is. Right? So the name x refers to the x value of the point, and the name y refers to the y value of the point. Right? Notice what's not here. Right? There's no colon or semicolon or hyphen or anything in here. Right? So there's no symbols. It's just @param and then the name of the parameter. The parameter name has to match the actual parameter name here. Right? It's not unusual that you'll write your code and then you go to document it later on, and then you'll decide later on that you want to change the name of the parameter. Right? If you do that, then you have to change the name of the parameter in the documentation as well. When you generate the documentation for this constructor, it looks like the following, right here. Right? So in the detailed section, right, you get a section called parameters. Right? The name of the parameter show up here. Javadoc inserts a hyphen or a colon or some other symbol here automatically, right? And then your description of the parameter goes here. So here's another example. This is the copy constructor, which also has a parameter. Right? So when we document the parameter other, right, @param other, and then describe what that parameter is. Right? So that's the point that you're copying. Notice here, Right? Notice here that when you refer to a parameter in someone who has actually taken the time to format their comments properly, that is typically formatted using @code. Right? Again, to offset the fact that that's a parameter and not just plain old text. Right? You can see that it gets when it gets generated into the document, it gets formatted as a different font. Okay, so the same thing holds for methods. Right? So every public method should have a Javadoc comment. Now methods return values. They may also throw exceptions. Right? So for methods, you're also going to document the return value. Right? So again, any parameters are documented with @param. The return value is documented with @return. So the method set has two parameters, returns a reference to this point. Right? So when you write the documentation for your method, right, @param new x, that's the x coordinate, new y is the y coordinate, and then @return, right, explain what it is exactly that's being returned. So in this case, you're returning a reference to this point. Right? If you were returning a new point, you would say a reference to a new point. Right? When you generate the documentation, you end up with a section that says returns, within a second, and that contains your documentation comment there. Question?
Is it a void method? Do we do anything special?
No, so if it's void method, there's no @return.
Okay.
Yeah, that's right. All right, so if a constructor or method throws an exception, you have to document the fact that it might throw an exception, or you should document the fact that it might throw an exception. The tag that you use here is @throws, and I don't know why they put the S at the end. Right? So for return, it's just @return. Right? It's not @returns. Right? this kind of makes sense because the keyword for return is return. Right? Why they made this throws, I don't know, because the keyword for throw is throw. It's not throws. So I don't know why they chose at throws, but that's what they did. So you have to remember it's throws and not throw. Right? When you document the exception, it's at throws, the type of exception that's thrown, when the exception is thrown. Right? So you want to describe under which conditions is that exception thrown. So for the counter constructor, it throws an illegal argument exception if the value is less than 0. Right? You can use math up here. Right? There's no reason why you can't write if value is less than 0 using the less than symbol. I never write it in because that tells you how to implement the constructor. And since normally I'm asking you to implement the constructor and put in the throws condition, I don't tell you how to do it. Right? So that's why you'll see whenever I write the condition here, it's always in plain English and not using the operators less than, greater than, and so on and so forth. It's actually annoying. I wish I could write the math in because it's a lot shorter. But anyway. So when you generate the documentation, there will be a section called titled throws. The type of exception is here. Javadoc inserts a symbol here. Could be a hyphen, could be a colon, could be something else. It depends on which version of Javadoc you're using. And then the condition under which the exception is thrown. If you know how to use HTML, then Javadoc will accept a subset of HTML tags in Javadoc. So for example, you can put in lists, you can put in, what else can you use? You can put in paragraphs, separate paragraphs. You can't use all of the HTML tags because Javadoc came out in 1995 and HTML has evolved since then. So there's only a small set of subtags that you can use. If you want to put in a separate paragraph, then you have to use the HTML p tag to indicate a new paragraph. Right? Just putting in the blank line won't create a new paragraph for you. And so this is an example of a 2-paragraph comment. Right? When you generate the documentation for this, right, it actually generates a second paragraph for that second comment. If that p tag wasn't there, then this would all be formatted as a single paragraph, even if you insert the blank line. All right, so I suspect that this particular slide doesn't apply to most of you. However, if you do plan on writing Java code professionally, then you really do need to learn how to document your code correctly. Right? If you click on that document there, that is the standard document that describes how you should document your code in Java. It's surprisingly long, this document here. Right? So I don't recommend you go through this for the purposes of this course. However, if you do plan on programming professionally in Java, at some point you need to read that document. Right? Because you will be expected in a professional environment to document your code. All right, so that's all the Javadoc you need to know for this course. Writing Javadoc or writing documentation for your code, I'm sure you've already realized can be a tedious process. It's not, most programmers don't like to do it. However, it is an important thing to do. It's also an important skill to learn if you're going to write code professionally. Right? Now, you'll notice that in labs 1 and 2, I never asked you to generate any documentation. 1, 2, and 3, right? Yeah, so I didn't ask you for any documentation. The reason being, it takes a long time to write, and you only have 2 hours in the lab. Right? Similarly, for 124, normally we don't ask them to generate the documentation, except for one of the assignments where they have to learn how to generate the documentation. Again, because it takes so much time to do correctly. Right? But at some point, if you're programming professionally, it's a skill you need to learn. Okay, any questions on Javadoc? It's relatively straightforward if you just follow the slides. I guess when you write your when you're writing your Javadoc comments, they're supposed to be written in correct technical English, which for most of you shouldn't be a problem because you're in engineering and you've written a bazillion labs by now, right? For the computing students, it's a bit more of an adventure because they haven't done a lot of labs. All right, any questions? Okay, moving right along. So now we want to talk about these things called preconditions and postconditions. And you've seen some of these in your labs already, right? You've seen the preconditions anyway, right? So when you write a method or a constructor, it's often the case that the method or constructor has some conditions on it in order for that method or constructor to run correctly. Right? So for example, if I want to take a point and divide it by some scalar value, right, to scale the coordinates of the point, then it doesn't make sense if the value that you're scaling it by is 0. Right? So I can't divide the coordinates of a point by 0. So that's an example of what's called a method precondition. Right? So a condition is something that's true or false. Okay? So don't forget that, right? So condition is always true or false, something that evaluates true or false. So a precondition is a condition that the caller of the method must ensure is true before they call the method. Right? So in other words, the precondition for divide is that s must be greater than or equal to, must be greater than 0. Sorry, the absolute value of s must be greater than 0. I wonder if I have the condition wrong. Sorry, just like, oh yeah, I just want to check something quick. Oh, that's fine, okay. Whoa. All right, so the precondition on divide is that the value of s must not be 0. Now, who's responsible for meeting that precondition, right? So here, it's the caller of the method, right? So it's whoever is trying to use the method that's responsible for making sure that the precondition is satisfied. Right? So if your method has a precondition, then that precondition should be documented in your Javadoc comment. Right? Now, Javadoc doesn't have a dedicated tag for preconditions. So how do you document it? So somewhere inside the description of the method or in the description of the parameter that involves the precondition is where you put the documentation for that. Right? So for example, here's divide. Right? So divide divides this point by a scalar value, changing the coordinates of the point. Right? In the description for the parameter s, we say that the scalar value, s is the scalar value that you're dividing the point by. Right? And now we say that it must not be equal to 0. So that's how that's how I've decided to document this particular precondition. Right? You could also put that in the text of the, or in the body of the comment itself. Oh, sorry. All right, so because the responsibility for meeting the precondition lies with the caller of the method, right, then whoever is implementing divide in this case, right, is allowed to assume that the preconditions are satisfied. Right? So for example, whoever is implementing divide can simply ignore the fact that s might be 0 when the method is called. Right? Now if you decide to ignore it, then it's easy to implement the method. Right? You just take x, divide it by s. You just take y, divide it by s, and away you go. Right? So in other words, the implementer of this particular method does not care if an illegal value of s is passed in. Right? They're just going to go ahead and divide by s anyway. Right? And this is a perfectly acceptable thing to do. However, there are some problems if you do this. Right? So the problem with assuming that the preconditions are met is that your method ends up running with inputs that are invalid. Right? And so that's going to have consequences. For example, if your method returns a value, it's probably going to return the wrong value. Right? In some cases, the method might encounter an error of some kind. In this case, you don't, but you might in other cases. Right? So if your method encounters some sort of error, it may end up throwing an exception, right, which isn't documented because you're not expecting or you're not considering the fact that one or more of the inputs may be illegal. Right? So you're not documenting the resulting exception that occurs. And now you can think of a method as being a contract between the person or between the caller of the method and the method itself. Right? So the method says it promises to do a bunch of stuff, assuming the caller meets some preconditions. Right? Now if the caller doesn't meet the preconditions, then it's usually the case that the method can't actually do what it says it can't actually accomplish what it promises to do. Right? And so now you end up with a problem where the method doesn't satisfy everything that's in its contract. Right? And finally, the method might end up putting the object into an invalid state. Right? So if you go ahead and divide the coordinates of the point by 0, then what ends up happening is the coordinates of the point become either positive or negative infinity. Or if x or y is 0, then the coordinates become not a number. Right? So floating point 0 divided by 0 is, always results in not a number. If you end up with a point whose coordinates are not a number, then whenever you try to use the coordinates of the point in arithmetic, the result is always not a number, right? Which may not be what you want to happen. Right? So in other words, it might be nice if the coordinates were never not a number. All right, so if we take our divide method and divide by 0, so if we take this point divided by 0, you end up with infinity and infinity, right? Which might be okay depending on why you're implementing this point 2 class. All right, so you can just go ahead and assume that the preconditions are satisfied. However, it's more often the case that you want to check, are the preconditions satisfied? And if they're not, indicate to the caller somehow that they've called the method incorrectly, right? And in Java, the way you do that is to throw an exception. Right? When you decide to throw an exception, you're going to document the exception. So the documentation for the precondition now becomes the documentation of the exception. Right? So we haven't really told you what exceptions are yet in this course. Right? So in Java, exception, the term exception is short for exceptional event. Right? So when an error occurs in a method or constructor, what ends up happening is the method creates an object and hands it off to the runtime system. So that object is called an exception object. Right? So that's why when you write, throw new illegal argument exception, right? The new keyword makes an object, right? The type of object is the illegal argument exception object. Right? The throw is what actually throws the exception. So when you throw that exception, the method stops running here. Right? Whoever called divide now ends up receiving an illegal argument exception object that contains information about why the exception has occurred. Right? So in other words, it contains information that the exception occurred in the divide method. Right? Whatever text is here also gets returned back to the method that called divide. Right? Now the method that called divide, it now has an exception object that it has to deal with. If it doesn't deal with the exception object, then whoever called that method ends up getting the exception object. Right? And so on and so on and so on until you get back to the main method. If the main method doesn't deal with the exception object, that's when the program stops running. Right? And then at the bottom, then on your console, you get this output that describes the sequence of events or the sequence of method calls that led to the exception being thrown. So that's what it means by hands it off to the runtime system. So there's lots of exception types that you can choose from. The common ones that you'll see in this course are illegal argument exception. So that's when you've passed in an argument to a method or constructor that's not valid. Right? You have definitely, you've almost certainly seen index out of bounds exception on the labs 1 and 2 when you're working with arrays, and 3, I guess. Right? So if you use an index that's not valid for an array or string, that's the type of exception that you get. If you try to use a reference whose value is null to call a method, you end up with a null pointer exception. Right? There's actually lots of exceptions that you can choose from in the Java language. So if you look up the exception class, you'll see that there's a whole bunch of exceptions here. All of the exceptions I just told you about are actually examples of runtime exception right here. And if you look at the runtime exceptions, you'll again see there's a whole bunch of exceptions that you can choose from. Right? So these are just the exceptions that are part of the standard library. You're allowed to make your own exception classes for your own classes if you want to. Okay, so this just explains what happens when you throw an exception, right? So your code stops running immediately after the exception is thrown, and then that exception propagates its way down the method, down the chain of methods that resulted in the method that threw the exception being called. Okay, so because your code stops running after you throw the exception, right, you want to avoid changing the state of your object before you throw an exception, right? So in other words, if you're testing the preconditions of your method, you should test the preconditions first and then change the state of the object once you know that the preconditions are satisfied. Hello? Okay, right? So for the divide method, if we decide that we're going to actually look at the value of s before we divide the coordinates of the point, then the first thing you do is test if s is equal to 0. Right? If it's 0, you throw an exception. Right? Now that we're throwing an exception, we document the exception up here. Right? And now there's your documentation of the precondition on this method. Only once you're sure that s is not 0 do you go ahead and divide x and y by s. Right? You don't want to divide x and y by s first and then check if the input was invalid. Right? Because that changes the state of your point to something that's probably not, to something that's invalid. And then it throws the exception. Right? You want the object to remain in its previous state before, after throwing the exception. All right, so that's a precondition, right? So preconditions, those are the responsibilities of the caller of the method. Right? You probably, in most cases, should test the preconditions in your method and throw an exception if they're not satisfied. If there's preconditions, it kind of makes sense that there's postconditions as well. Right, so a postcondition is a condition that the method must ensure is true immediately before the method finishes running. Right? So the instant that the method is done running, the postconditions for that method have to be true. Who's responsible for the postconditions? It's the implementer of the method now. Right? So if your postconditions are not true, then you've probably made a mistake when you went and implemented your method. All right, so what are postconditions on a method? So if your method returns a value, then there's a postcondition or conditions on the value that's returned. Right? If your method changes the state of an object, like set, right? So set for points changes the x and y coordinates of the point, then there's a postcondition on the fields, involving the fields of the object. I don't think we've seen an example of this yet. Have we? Have we seen one of these? I don't know if you've seen one of these yet. So some methods will take in an object reference or an array. Right? Those methods might change the state of the object that's passed in or the state of the array that's passed in. Right? So those methods have what are called side effects. Right? They affect one of the parameters. If you have a method like that, then there will be a postcondition involving the parameter. So whatever postconditions you have, they're normally described in the documentation of the method, but they don't appear as actual conditions. Right? So in other words, you won't see anything that says something, something, something is always true or false. Right? So for that, I mean the following. Right? So here we've got a method x, right, that returns the x coordinate of the point. Right? This method does have a postcondition. Right? It promises to return the coordinate of the point. Right? But that's not expressed as an actual condition. Right? So in other words, it's not expressed as something that's either true or false. So normally postconditions are written in plain English rather than writing them out explicitly mathematically. Okay, so what happens if we try to actually write it out mathematically? Right? What is the postcondition for that method right there? Right? So in other words, I want to write some Boolean expression that describes what this method does. Right? It's possible to do, but it's extremely awkward. Right? This method here, which does almost nothing, right? We agree that this is the simplest method. I think everybody agrees this is probably the simplest method that you can implement. Right? To write the postcondition for this method is surprisingly complicated. Right? So here we go. So if I want to write this postcondition out in Java, you have to do the following. Or you have to do something that's similar to the following. So my method x now changes. So the first thing I do is I make a final variable called old x, and I set its value to this x. Right? Now remember what final does. Final means once I assign a value to old x, I can't change old x. Right? So in other words, old x is the x coordinate of the point when we call the method. Old y is the y coordinate of the point when we call the method. Result, that's going to be the x coordinate of the point when we call the method. Right? I guess this should technically be, well, it's fine the way it's written. Right? Then I can return the result. Right? Now, this right here, just before you return the result or just after you return the result, is where you want to write the postcondition or where you want to test the postcondition. Right? So what is the postcondition for the method? It's the x coordinate of the point is unchanged. Right? So this x equals old x. Right? The y coordinate of the point is also unchanged. Right? And the value that was returned is the same as the x coordinate of the point. Right? So that's what you have to write in order to actually express the postcondition for this method mathematically. Right? Which I guess we can all agree is both surprising. Right? You wouldn't think that you'd have to write all of this, and also awkward to do. Right? You need to remember what is the state of the object when you called the method. Right? Then you need to check, did the state of the object actually change? You want it not to change. Right? And you also have to test, is the correct value returned? Right? Now you might ask yourself, so why on earth would you want to do this? Right? And so the reason you'd want to do this is because there are programming languages which actually check the preconditions and postconditions of all methods and constructors when they run. Right? So the languages that do this are the languages that are used for mission-critical applications. Right? So stuff like sending satellites up into space, medical devices, hopefully, but probably not, since I actually work in that field. Right? I can guarantee you they don't. It'd be nice if your car, the computers in your cars actually check pre and post conditions, but they don't either. Right? And so on and so on and so forth. Right? But there is a relatively small set of languages that actually do this sort of checking. Built into those languages are the ability to not have to do this sort of stuff here, like remember the state of the object when the method was called. Right? Those languages have facilities that do all of that automatically for you. Right? The languages also automatically check, are the preconditions satisfied, are the postconditions satisfied? However, it's the responsibility of the programmer to actually express the pre and post conditions mathematically. Right? So there is a reason why you'd want to do this. The reason you want to do this is because if you can express if you can actually express the mathematical behavior of your program, you can then prove that your program is correct. Right? One of the ways that you do that is by expressing the pre and post conditions mathematically. Right? So there is a whole field of research, or I guess of engineering practice, software engineering practice, called formal methods that is involved with this sort of thing. Right? With rigorously proving programs are correct. Right? How do they do it? It's all math. Right? So there are people interested in this sort of thing. There's not a lot of, I don't think there's a lot of widely used code that's actually rigorously checked using formal methods. But people are trying to do so. Okay, let's look at one more example and then we'll end it there because I don't want to beat a dead horse. Right? I'm never going to ask you to do this anyway. So let's look at an example of a mutator method. Right? So the method that changes the x coordinate of a point. Right? How would I express the pre and the post condition for this method here? Right? Well, it's pretty similar. Right? So the method x changes the x coordinate of the point. Right? So if you think about it, what should happen after the method runs? Right? The x coordinate of the point should be equal to new x should be equal to new x for the value of new x that was passed into the method. Right? The y coordinate of the point shouldn't change. Right? So I'm going to remember what the value of new x is when I passed it into the method. Right? So I'm going to call that param x. Right? Now why do I have to remember what new x is? Because someone can write silly code like this. right? Someone can come along and change the value of new x somewhere inside the method, right? If you change new x here, then this line of code is wrong here, right? Now you're changing the x coordinate of the point to 1. You're not changing it to new x, right? So you have to check. You have to remember what is the value of new x when you called the method. I also have to remember what is the value of the y coordinate when we called the method. Right? And then finally, I need to know what is the correct return value. Right? Once I have all that information, I can actually formulate the postcondition. Right? So the value of x after the method finishes running should be the original value of new x. Right? The value of y after the method finishes running should be the original value of y when the method was called. Right? And the result that's returned, or the value that's returned, should be a reference to this object. All right, so is there a way to check the postconditions? So that's the problem, right? You want to check the postcondition here, right? When the method finishes running. Yeah, question?
What was the point of making that final param x if you still did like this dot x equals 2x?
Oh, so this method is wrong. So if you check the postcondition will tell you that the method's wrong. That's the point of this slide. Sorry, I didn't explain that. That's a good question, right? So yeah, that's why you have to remember what new x was, because you can change new x inside the method. If somebody does it, the method's wrong, right? In this example here, you just look at it and say, well, that's wrong, right? But if you had a really long, complicated method, it's very easy to accidentally change a parameter, and that will mess up, or that will possibly lead to errors in the final result. That's the other problem with teaching this sort of stuff, right? We always use simple examples, and you just say, well, that's wrong, right? But when you actually look at real code, it's much harder to find these bugs. Yeah?
So for writing longer code, would it be a good idea to check to make sure that your conditions you called in aren't changed?
So the answer is typically no, unless you're in a language that actually does pre and post condition checking, right? But then those languages will normally do it for you. They'll have facilities for you to actually do the sort of checking. In languages like C or Java or Python, where these abilities aren't built in, it's way too awkward to do. Yeah.
What's a language that requires pre and post?
Not requires, but can check. So APL is one. Eiffel is another. Okay, so how do you check the post conditions? So can you check the post conditions if you really wanted to? The answer is yes, you could check the post conditions, right? So you can't do it when the method returns, right? Because you're not allowed to put code after the return statement. But you can put it right before the return statement, right? Now the problem is if you put this into every one of your methods, every time someone calls your method, they have to pay the price of this, checking this post condition. This post condition is relatively easy to check. You can easily imagine a method where the post condition is very expensive to check. Right? So for example, imagine writing a sorting method that sorts an array, right? Try to formulate the post condition for that method. And you'll quickly realize that it's, one, not easy to do, and two, it's also expensive to check. Right? So everybody who calls your method is now paying for this test of the post condition. So there is an alternative way to do this. You might have seen it in your C course if you ever used assert, right? Java also has assert statements. So assert statements you can turn on and off. The way an assert statement works is that you pass it some condition that you think is true. If the condition evaluates to true, the assert statement does nothing. If the condition evaluates to false, then the assert statement causes your program to stop, right? So it throws an error in that case. Now the nice thing about assertions is you can turn them on and off. So when you compile your program, you can either activate or deactivate assertion checking. So the idea here is that when you're developing your program, either developing, testing, or maintaining your program, you turn assertions on to help you find bugs. When you're confident that your code is correct, you turn them off. So that disables that disables the testing of the assertions. Right? So instead of writing that if statement, you just replace it with an assert statement. Right? If you want to do this sort of thing in Eclipse, so assert statements are actually quite useful when you're developing code because they do help you find lots of little bugs that can easily creep in. right? However, they're turned off by default in Eclipse. So even if you put them in, when you run your program, they don't get evaluated. So you have to explicitly turn them on. There are the instructions for turning them on. You can follow the similar set of instructions for turning them off. Right? So that's if you want to use them in Eclipse. If you're using something else like Visual Studio Code, I actually don't know how to turn them on in code. My suspicion is you have to call the compiler yourself and tell the compiler to turn them on or off. Okay, so what other types of conditions are important? Sorry, oh, I guess we should stop there because we got to mosey on over to the lab where there's a lab test. So we'll pick this up in the next lecture.